Hey everyone, today we will see problem number 916, that is word subsets from the lead code, and this one is a medium level problem. So as input we have two string arrays, word 1 and word 2, and we have to check the strings in word 2 are subset of strings in word 1 or not. So they define a subset as a string B is a subset of string A if every letter in B occurs in A, okay, including multiplicity. Multiplicity means that we have to check, we have to keep in mind the number of times a character occurred. For example, WRR is a subset of warrior, but WRR is not a subset of word because we need R two times and word only have one R. Okay, these are some examples they have given. Some some strings in array word 1 and some substring in the word 2, and we have to return a list of string, the list of valid string as output. Okay, let's check the example. So there are two approaches. First is brute force, which have a very high time complexity, and the second one is an alternative, which is somewhat efficient than the brute force one. Okay, so by brute force approach, we are comparing all the substring individually with words, all the string in the string array, for which we have to check the substring or substring. Okay, this is like we are checking E in Amazon and then we are checking O in Amazon. Okay, let's take an example that first we are checking E in Amazon. Okay, E is not there in Amazon, so Amazon is out. Okay, now then we go for the next one, Apple. Is E is there in apple? Yes, E is there in apple. Okay, then we check for O. Okay, we again go for checking for the next substring. Is O is there in apple? No, O is not in apple, so apple is out. Now, likewise, we are checking individually with all the substring and every pair of substring and the word. Okay, but in the alternative, what we can do is we can combine all this substring with one final string, and then we compare this final string with all the words individually. So a time complexity will improve. And how we combine that? First, we create an empty substring. We have created empty substring. Then we are iterating with all the substring ELO. Then ELO is not initially in a final substring, so we have added ELO. Okay. Now we check for the next substring OE. O is there in substring? Yes, O is there. Then E is there in substring? E is also there, so we don't need to add anything else for the second substring. Now we are checking for the third substring DE. Is D is there in our final substring? No, D is initially not, so we have added a D. Now the next character is E. Is E is there in a substring? So let's take one more E in this substring. So E is there in substring? Yes, E is there in substring. So we don't need to add an E in the final string for this E, first E. But if there is one more E, that is DE is our substring, then here in our final string there is only one E currently present. So we have added one more E in this. So it becomes ELOED. Okay. So we have created a dictionary for this final string, and and then we create a dictionary for all the words one by one and compare the values of this final substring and the words. Okay. how we create dictionary? We have a final substring ELOED. E two times, so E is the key and 2 is the value. Likewise, L is the key and 1 is the value. O is the key and 1 is the value. D is the key and 1 is the value. And for apple is the word. Words in the word 1 array list. Okay. So A comes one time, so A key and 1 value. Likewise, P comes two times, so P is key and 2 is the value. Okay. Now for substring, this all letter should be included in a word. So E, we need E two times, but we have in apple E only one time. So apple is out of our final list. Now we check for the next word, lead code. We need E two times, we have E three times. Okay, this one is valid. More than that occur, so it is valid. Now we need L one time. Minimum we need one L in a word. So if we have L one time in L, so this is also valid. Now O is do we have O one time in at least one time in lead code? Yes, we have. So it is valid. Now we check for the last character in the final substring D. Do we have D in our lead code? Yes, we have D. So lead code will enter in our final list of array, list of strings. Okay, and our outputs list string. So we have written a code in C sharp. Uh, so there is a function word subset which have two inputs, string array, in the form of string array, word 1 and word 2. Word 1 consists the word and word 2 consists the substrings. Okay, and we have to return a list of string. So we have created a list of string. Then by the we have written a function create substring dictionary. By this we have created dictionary for the final substring. First we have created a final dictionary, final substring, and then we have created a final dictionary and then written that final dictionary for the final substring. Okay, so we in here we get a dictionary for the substring. Now, for iterating for all the words in word 1 list array, we are passing this word and a substring dictionary to the function is substring. Okay, in this function, we are first declaring a temporary dictionary for the word. We are first uh, filling the values in the dictionary by iterating over the word, and then we are checking, comparing the dictionary with a substring dictionary and returning the result accordingly. If the value is less than the desired value, then we return false, and if the value doesn't contain in the word dictionary, then we return false, otherwise we return true. So if we return true, then the word is added in our final list of string. Okay, and after iterating all these words, we have written the our final list of string as output. By this, your all the test cases will get passed. Thank you.